Hello friends. So far we have seen various concepts and theory related to the flywheels in the previous sessions. Now we will take up problems on flywheels. Here I not only solve previous gate questions, we also take up some of the problems so that it will give more insights in the concept that we have already learned in the previous sessions. And here further we proceed to solve these problems. I would like to memorize the formulas that we have already derived in this session or the previous sessions. So first under the bending moment diagram equal to mean torque into period of the period of that particular engine. So here this period is in terms of radians. So it could be either 2 pi or 4 pi, it depends on the period of that particular function. And this in term can be written as 0 to period p torque. This torque is produced, engine torque produced by the fuel burnt into d theta. So this theta would be integrated from 0 to the period of that particular mechanism of the engine or engine. And after that we can calculate power produced by that engine equal to T mean into omega. So here what we need to remember is always T mean is used whenever you want to calculate either energy or power. Why? Because T mean is always considered constant, that we have already seen why this is a constant in that particular example where we have taken the car with the four persons that has to be moved from one place to another place, and this is the formula to calculate the power. And from this formula can I write this one, T mean equal to 1 by period p into integral 0 to p torque inside the engine torque into d theta. So in so many examples, um, simply engine torque will be given in terms of sine and cosine curves terms. So we need to calculate period of that given particular function and integrate from 0 to period of that, 0 to period, by multiplying the torque with the d theta and divide the whole value with the period. Then we will get the period of we will get mean torque. That's how we need to calculate. After finding out the mean torque, you substitute this mean torque into the power formula. That's how we will get power. And then we also derived coefficient of fluctuation of speed, that is cs, for flywheel, that is omega 1 minus omega 2, where omega 1 is the maximum angular velocity of the flywheel and omega 2 is the minimum angular velocity of the flywheel, divided by mean of these two, that can be written as omega, where here omega equal to omega 1 plus omega 2 by 2. And we also derived formula for the fluctuation of energy. This is not a coefficient, unlike this one. This is just a value, so it has a dimension also. So this one is I, that is the moment of inertia of the flywheel, I, and omega square, that is the mean angular velocity of the flywheel, into coefficient of fluctuation of speed cs. So we have already seen how to calculate dE for various engines, and we have seen I for various types of flywheels. That means if it is a solid disc, or what if it is a ring type of flywheel. And we have also derived remembered a formula for for the flywheel if it is a torus type. And we with these formulas now we proceed to solve different problems. um, First of all, we will take this problem, and first let's read the problem. The torque exerted on the crankshaft of a two-stroke engine can be described as they have given torque developed inside the engine is this one. This is not constant, but as we have seen here, this is the sine theta and cos 2 theta. Um, and resisting torque is constant. What is the resisting torque? That is torque demanded by the output load. So that resisting torque is T mean or Ts equal to T mean, that we have already seen in the previous session. So the power developed by the engine, he is asking power developed by the engine. So what is the formula for power? Power P equal to mean torque into omega, where omega equal to 2 pi n by 60. So we need to calculate here T mean, but we don't know T mean. So we also know, but we know how to calculate T mean. So T mean equal to 1 by period into 0 to period T d theta. So we need to calculate first period. So for a given function, or for a given torque, we have sine theta and sine 2 theta. So LCM of sine theta period and sine cos 2 theta period. What is the sine theta period? That is 2 pi. And what is the period of cos 2 theta? That is 2 pi by 2. So this we have already seen in the previous session, how to calculate the periods. So LCM is 2 pi. So here period of the given function is 2 pi. So here Tm equal to 1 by 2 pi into 0 to 2 pi 10 power 4 plus 10 cube sine theta minus 1200 cos 2 theta. And if you integrate this one, this become 10 power 4 into theta, and here we have d theta. Let me erase that one. LCM, I am erasing the LCM. We have already seen how we calculated the LCM, and this is the theta, and here minus integral of sine theta is minus cos theta. So 10 cube cos theta, here minus 1200 cos, integral of cos 2 theta is sine 2 theta by 2 into sine 2 theta by 2. We need to substitute 0 and 2 pi in these values. So for example, if I take a cos term, if I substitute um, 2 pi in the cos theta, that is the 1, and if I substitute 0 in the cos theta, that is also 1. So 1 minus 1, it becomes 0. And sine 2 theta, if I substitute 2 pi in the place of theta, then it's a sine 0. 0. And again, if I substitute 0 in sine 2 theta, again that's a 0. So this term also becoming 0. So we have only 10 power 4 into theta. And if I substitute 2 theta here, it become 2 theta. But here already we have a 2 theta. So this will become 10 power 4 into 2 theta by 2 theta. Sorry, 2 pi by 2 pi. So this will get cancelled, and we will get to 10 power 4. So here what we can remember is, in not only in this case, in whichever case, if the torque is given like this, and if we want to find out the mean torque from the given engine torque, we can simply consider the constant term as the mean torque. We can consider constant term is the mean torque. Why? Because if you integrate these sine and cos terms from 0 to period, those will become automatically 0. So we can consider only constant term as the mean torque. So while solving for gate exam, we can directly take this constant term as the mean torque. But if the same question is asked in the IES, then we cannot take directly this one. So instead, you follow this procedure and prove that T minimum equal to 10 power 4. Why? Because in that exam, in the conventional paper, procedure is important. And here power P equal to T mean, that is 10 power 4 into omega equal to 2 pi into n is 100 rpm. When it is rpm, you divide with the 60. So this will become 0 0 get cancelled, 2 in this one 3 times. So 10 power 5 pi by 3. This is the what is the units of power? Watts. That is a joule per second. So this is the answer. So here what are the formulas that we have used? Once again, let me see what are the formulas that we have here. First of all, we need to calculate power, that is a T mean into omega, but we don't know T mean, so we need to calculate T mean from the given values. So but we know T mean equal to 1 by P into 0 to P T d theta. This we have derived from the energy equation. So this is as simple as that. And let's see other examples here. Asking 2001, it's a 1 mark question. They ask for 1 mark question. So we need to choose a correct statement, and they are talking about flywheel, and another one is, here we can see, governor. So first of all, we need to know what's some function of governor. We already seen that flywheel function. So what is the function of flywheel? Let's recollect from the previous sessions. Flywheel. Uh, what is the function of flywheel? Flywheel, it reduces the fluctuation during a cycle, that is during a cycle, and it won't reduces the speed of the engine, sorry, speed of the vehicle. Now in the car example, the driver is cruising at a particular speed with a constant load. Here load as a constant, and vehicle speed also constant, but because of that, we are getting some fluctuations in a cycle, so we need to reduce the fluctuation in the cycle. That's what the flywheel is trying to do. So let's read the first statement. Before reading the first statement, I would like to explain about the governor also. But governor, actually these governors are used to control the fuel flow in an engine. So for example, in the same car example, where we have, this is the car where we have so moving in the direction with the 4 persons, and if at this particular load and speed, fuel, for example, fuel is F1, we are supplying F1 amount of fuel, and suddenly if 2 persons are getting out of the car, and load also decrease, but if you keep on giving the same amount of fuel, either it will move with the higher speed, so it will move with the higher speed, but if you want to maintain the same constant velocity v, what we need to do, we need to cut out the fuel. So how to cut out? So that's where governor comes. So governor is sensitive to the output load variations. Governor is sensitive to the output load variation, but it is not concerned with the per se cycle within the engine. So, for example, um, if load is increased, then we need more fuel to run the engine. So, that in that scenario, governor allows more fuel for the combustion. So, governor allows the fuel, and when load is decreased, governor decreases the fuel supply. So how it decreases fuel supply with respect to load, detailedly we discuss detail when we deal with the governors. So we understood now what is the main difference between flywheel and governor, and let's go back to our statements. First one is, and this they have given flywheel reduces speed fluctuation during a cycle for a constant load but flywheel does not control the mean speed of the engine if the load changes. Yes, that is true. Flywheel doesn't control the mean speed. That mean speed is controlled only by changing the fuel supply. And so this is the correct one. And let's see second one. Flywheel does not reduce the speed fluctuation. This itself is a wrong one. This is wrong one. The main function of the flywheel is to reduce the speed fluctuation during a cycle, right? So this itself is wrong. And let's see third one. Governor control the speed fluctuation during a cycle for a constant load. Main aim of governor is to control the main speed, but here they are saying it does not control the mean speed of the engine. So this is the wrong. And the governor controls speed fluctuation during a cycle for a constant load, and the governor also control the mean speed of the engine if the load changes. Governor doesn't control fluctuation during a cycle. Okay, so this is the wrong. Here in the above option C, governor controls speed fluctuation during a cycle for a constant. Here also they have mentioned it is as a during the cycle. This is also wrong, right? So B, C, D are wrong, and our answer is C. Sorry, answer is A. This one has been asked in 2012 for 1 mark, 2012, and let's see this one. Um, Solid disc, circular solid disc of radius this much and thickness this much, and they have given mass also. Now this solid disc is used as a flywheel, and it's rotating at 600 rpm. So we need to find out kinetic energy of the flywheel in joules. So this is a straightforward problem. So what is the formula for kinetic energy for of any rotating body? That is half I omega square. That is as like in a linear motion half m square. So for a circular disc, what is the I? That is mr square by 2. So mr square by 2 into omega, that is 2 pi n by 60 whole square. So let's now substitute the given value in the formula. So what is the m? That is 20 into radius. Radius equal to 200 mm. We need to change into meter. Mm. So multiply with 2, 10 power minus 3, 2, that will become meter. So if you multiply 200 with 10 power minus 3, it becomes 0.2. So 0.2 whole square divided by 4. This 2 and this 2, 4 into 2 into 5 into 600 by 60. So if you calculate this value, you get approximately 790 Newton meter. Otherwise, that is a joule also. So this is a simple one. It has given in 1998 for 2 marks. So let's read the problem. A flywheel of moment of inertia I, they have given I, that's a fluctuates by 30 rpm. So they have given how much amount of velocity it is fluctuating. So that means they have given omega 1 minus omega 2, but here the units are rpm. So it is a n1 minus n2 for a fluctuation of energy this much. So they have given delta E also. So what we need to find out the mean speed of the flywheel, that is omega. So first let's write down the given variables. Sorry, given values. I has given, delta I is given, and they have given n1 minus n2 equal to 30 rpm. So fluctuates by 30 rpm. That means omega 1 minus omega 2 if it is a radian per second, but here it's mentioned rpm, so this is a n1 minus n2. So this is a fluctuation. Speed fluctuation, this is nothing but speed fluctuation. And this is again a directed formula. We know delta E equal to I or we directly derive that one, half into I into omega 1 minus omega 1 square minus omega 2 square. So this in turn can be written as I by 2 into omega is 2 pi n by 16. So if you write this one, then n1 square minus n2 square into 4 pi square by 60 square. And again this can be written as um, 2 pi square I by 60 by 2. This 2 will cancel 2 times in this 4 into this can be written as n1 minus n2 into n1 plus n2. A square minus b square equal to a plus b into a minus b. And can I write 2 here and multiply 1 2 here? So this will become n, that is the mean speed, and this has given, and delta E is given, so let's substitute the values. So delta E equal to 1936. All these values units should be in the uniform, that in compliance with the SI system. And 4 pi square, this is the square, into I 9.8 kg meter square divided by 60 square into 30 into n. And if you substitute this one, we get n value equal to approximately 600.483 rpm. So our answer is A. Let's read the problem. For a certain engine having an average speed, so they have given average speed. So what is the average speed? Omega, or here it's mentioned as a n. So because the units are in rpm, that is a 1200 rpm. A flywheel approximated as a solid disk, so that means I equal to mr square by 2 is required for keeping the fluctuation of speed. So let me underline this one in a red color. So this is a fluctuation of speed within the 2% of the average speed. So what is the fluctuation of speed? That is a delta n. It should be within the 2% of the average speed. So this is the 2% of the average speed n. Here let me deviate further. So here they directly mention that fluctuation of speed is the within the 2%, but in sometimes in some other cases he may give that fluctuation of energy is varying plus or minus 2% of the mean speed. So if it is mentioned like it, yeah, these speeds are within the limit of plus or minus 2% of omega. So in that case, what will happen? Omega 1, that is the maximum speed, equal to 1.02 into omega. And what is the omega 2? That is the minimum velocity, that is 1 minus 0.02 omega. Here how we got this one? This is 1 plus 0.02 into omega. Here this omega is 4 or 4. This is how we need to get. Now how much we get here? 0.98 omega. So if you do omega 1 minus omega 2, again we get 0.04 omega. So if he make if it is mentioned like these fluctuation of speeds are plus or minus 2% of the omega, then we need to proceed like this. But here, instead of mentioning like that, he directly given that fluctuation of speed. He himself given directly fluctuation of speed, that is a delta n is 2% of n. So we need to observe the difference between asking like this or asking like this. And let's go back to our problem. uh, Here delta n is given directly, and next one is and he has given fluctuation of kinetic energy, that is delta E is 2 kilojoule. Then he is asking what is the least possible mass of the flywheel if the diameter is not exceed 1 meter. So for a limiting case, so we take a limiting case, that is what is the mass of the flywheel if we take diameter as a 1 meter. So here d equal to 1 meter, that's a given, and delta E equal to 2 kilojoules, that is also given, and a average n is given, and we know I for a solid disk equal to mr square by 2. So a simple one. So we have the formula delta E equal to I by 2 omega square, not 2 omega, I omega square into Cs. So what is the Cs? Cs equal to n1 minus n2 by n1 plus n2 by 2. Otherwise we can write delta n by average speed n, but we know delta n equal to 2% of n, so 0.02 n by n. How much? This is 0.02. This is the Cs, and we know omega also, that is in terms of n. Then we need to calculate mass. So if you write this one further, m r square by 2. So if you convert that one, r square, that is mr square by 2. But if you divide with 4, you multiply with 4 and divide with 4 into, this is 2 pi n by 60 whole square, and Cs equal to delta E. So m equal to, this becomes d square, m equal to delta E into 8 by d square into 1 by Cs into 60 square by 4 pi square n square. And here we need to remember delta is 2 kilojoules. That means 2 into 10 power cube into 8 by 1 cube into 1 by 0.02. It is 60 square by 4 pi square. N is 1200 rpm. So if you solve this one, approximately we will get 51 kg. So this is the mass of the flywheel. So this is also again